This outpatient visit recorded approximately 38,000 patient visits, but each procedure system here contains over 62,000 records. So which number contains the true patient activity? You know what? Both numbers are correct. They simply describe different healthcare events. And the thing is, the problem starts when someone starts treating both events as the same. And today, I'll show you how to model these two different events without correcting the grain. So the sponsor of today's project is Dr. Helen Carter. This is a fictional name, not real. Nothing here is real. She wants a reliable foundation on two very important questions. And the number one is, how many patients visit the hospital? Let's say monthly, yearly, or even daily. And what procedures are being carried out during those patient visits? Those are the two questions that she will want a reliable foundation built upon. If you take a careful look into these two questions, we're talking about having a strong foundation around the patient visits. And then the next question is the procedures that happen during these patient visits. If you look at this question, they are both related. But the truth is, they do not share the same grain. This is because one visit can have multiple procedures. Instead of trying to force everything into one big table or one large table, we are going to build two fat tables. One at the encounter grain. Encounter here means visits. So one at the visit grain and the next one at the procedure grain, the procedures that happen during each visit. So you see, that distinction between these two different fat tables protects every matrix you build upon each of these fat tables. All right, let's look at the relationship between these tables before we even build anything. All right. The source data we are going to use for this demo sits in the public schema of the healthcare database. And here I have the healthcare database actively selected. And if you go down, you will notice I've got two schemas. One is the healthcare OLTP, and the other one is the public. We are going to dwell more on the public. So I'm going to expand it. So expand the table. We've got 18 tables. And the tables of interest for us are the encounter table and the encounter procedure table. The encounter table records patient visits, while the encounter procedure tables record the clinical activity or clinical work performed during that visit. So we are going to prove a relationship that exists between these two tables. When you check this query here, you will notice that I have selected two important fields and did a calculation on one. And those are the encounter ID from the encounter tables, the patient ID from the patient table, and then I did a count of the line number, which represents the activities that happen or the procedures that happen during the encounter visit. And this will be coming from the encounter procedure table. All right, so I'm going to go ahead to group them by the encounter ID and the patient ID. And then what we are more interested are on those visits from each patient that has more than one procedures performed. And that is why we are also filtering where the count of the line number is greater than 1. And then we are going to order them by the procedure count in descending order. Only get the first 10. So I'm going to run this. And then we have this. When you look at this query output carefully, you will notice that we've got a patient who visited with this visit ID or encounter ID. And during this visit, there were up to 5 procedures that were performed on these patients. And the same thing with the others. Well, it's a coincidence that we've got 5 only for all of them, but the message is clear. This is more than one procedure. And this becomes really crucial when we build our facts table. So now that we have proven this relationship, you will notice that one encounter appears against several procedures, and this is expected. The encounter represents the visits. Each procedure records one unit of the clinical activities that happen during that visit. Based on this understanding, we can now build our facts table correctly. All right. The first fact table that we will build will contain one row per completed encounter. So this will be at the level of the encounter. We also want the number and the value of each procedure associated with that visit. But notice one thing here. We do not want to join the raw procedures directly. We will risk multiplying the encounter. And that is the reason we summarize the procedures first. Alright, so here is the query that creates the facts table. If you carefully look at this design, you will notice something. The procedure summary contains one row per encounter or per visit. That means joining it to the encounter table does not change the grain. The final result remains one row per completed visit. Before I go on and run this query, I will explain it to you. The first line creates the schema if it doesn't exist, and if it exists, it doesn't do anything. And the next creates the table. Now, when you go down a little more, you'll notice that the next line up to the end represents the query. All right, so this represents the main query, and I'm going to run it on its own. It runs properly, and you can see that it ran successfully to produce this record. However, this record is not saved anywhere. For it to be saved, I need to run it alongside this one, so that when it runs successfully and creates a table, it inserts the record inside this table. So to do this, all I just need to do is execute this script from this button, which will execute all the scripts, including creating the schema, the table, and inserting the record into the table. So I will run this, and that ran successfully. So now it feels like nothing has really changed. But when we go on, remember we had just two schemas here, and these are the healthcare OLTP and the public. But if I right click on schema and refresh it, you will notice that we've got three schemas now, and the additional one is the analytics. And I'm going to expand the analytics, look for the table that we just created, and these are the tables. So you notice that we've got one table here, and that is very successful. All right, as it is, we have been able to successfully create this facts table, but we need to enforce some rules. In other words, we're going to alter this same table and tell Postgres that we want the encounter ID to be the primary key. So it's so simple. I'm going to paste this code here. This is just 2 lines of code that does it. All right, so I'm going to run this, and we have successfully enforced that primary key. And that is it. All right, this is now a strong and correct foundation for visit counts, encounter duration, provider activity, and departmental workload. Which leads us to the second facts table. And honestly, the second facts table actually answers completely different question from the first facts table, which heavily depended on the encounter. Now, the second main question is, what clinical workload happened during those visits or those encounters? In this situation, we will preserve the procedures, and this is very important, not just the encounter. Because we are just working with these two tables, we will not aggregate back to the encounter as we did in the encounter level. We will just preserve the procedure. All right, so I will paste this query here. Let's take a look at this. So I want you to take note of what is happening here. We are only interested in records where the encounter status are closed. We are talking about visits that have been completed. We're not talking about open visits, maybe the ones that have not come. No, we want visit that has happened. That's why we say where the encounter status is closed. All right. So at this point, what happens here is that we will create the table again. We don't need to create the schema. We'll create a table. I will name it FAT Encounter Procedure. Notice the first one, we name it FAT Patient Encounter. This is the FAT Encounter Procedure. And to be honest, you choose what you will name it. And this needs to be descriptive, consistent with what the business unit wants. I am going to run this. And yeah, it ran successfully. Good. Now, after running it, we need to do something. One encounter may now appear several times because this is not encounter grain. This is the procedure grain. At this level, each row represents one procedure, and there can be multiple procedures for every encounter or visit. So to be able to ensure that the key reflects a lower grain, we are going to now alter the table and create a primary key for it. And the primary key for us will be a combination of encounter ID and the line number. So I'm going to paste this code here and run it. Very simple. Good. And we have been able to enforce that ID. So the combination of encounter ID and the line number uniquely identifies the procedure. In this case, the grain has changed from encounter to procedures that were performed during the encounter. The same way, the key will need to change. All right. Now let's go further and prove the difference between these two fact tables that we have created. So I'm going to paste this code so that you will see everything here. All right, so here is the query, and when I run it, we have this. Excellent. When you take a look at the output, you will notice that the encounter fact table contains one row for every visit. However, the procedure fact table contains more rows, and this is because one visit can contain several procedures. And this is the reason why when you count encounter ID directly from the procedures or activities that happen during the visit, you will produce facts that are heavily inflated by visit counts. The truth is that the data is not really duplicated. What changed here is the level of details. All right. Now you see that the same episode of care can produce multiple facts, or you can say multiple fact tables. Now, one tells operations how many visits took place, while the other tells clinical leaders the procedures that happened during those visits, or the activities that took place during those visits. But there is one thing that we must take into heart here. Neither of these grain is wrong or better than the other. The correct grain to use is the one that preserves the business event being measured at this point. So you need to understand what you want to measure before you write the first line of SQL query. Alright, in the next video, we are going to extend this same principle into the world of e-commerce, where one website visit can generate multiple events. So I'm going to see you there. Alright, if you got value from this video, please give this video a like. Amanda, just go. Go and sit down there. Please give it a like and share it with your friends so that you too can recommend it to people who truly will need this and people who will use it at their workplaces and even businesses that can benefit from this. And share it amongst your friends. If this is your first time coming to my YouTube channel, please consider subscribing. And if you are my returning subscriber, I said thank you. Thank you so much. I see what you do and I appreciate it. Thank you so much. And until I see you again, keep analyzing.